Right now, as you watch this video, a $150 billion machine is racing above your head at 28,000 kilometers per hour. And at this very moment, someone is living up there, witnessing 16 sunrises a day, drinking recycled coffee, floating in zero gravity, and surviving in one of the most dangerous environments ever created by humankind. This is the International Space Station, the most expensive, most complex, and most ambitious structure humans have ever built in space. But behind the stunning views and groundbreaking science lies a constant fight for survival. Even a small fire inside the station could turn fatal within seconds. Micrometeorites, moving 10 times faster than a bullet, could tear a hole through the station. And yes, the same water you drank yesterday might be in your coffee today. In this video, we go far beyond the headlines. We are revealing 10 mind-blowing truths about the ISS. Stories that are rarely told, risks you never imagined, and facts that will change the way you look at the sky forever. Are you ready to discover what life is really like aboard the International Space Station? Hi friends, welcome to a brand new video from Science Simplified for All. Today, we are diving into the International Space Station, or ISS for short. We have arranged 10 amazing facts in a countdown format. Facts you definitely need to know. We often imagine the International Space Station as something far away in deep space. But in reality, it orbits just 400 kilometers above Earth's surface. Compared to Earth's diameter of 12,700 kilometers, that distance is incredibly small. If Earth were the size of this globe, the ISS would be orbiting barely 1 centimeter above it. To put that into perspective, astronauts aboard the ISS are actually the closest neighbors to people living on some of the most remote islands in the Pacific Ocean. Even when the ISS is flying directly above your city, the astronauts on board might be closer to you than people in neighboring towns. So, despite how we picture it, the ISS is not some distant or unreachable object. It passes right over our heads regularly. And on a clear night, if you look up at the right time, you might even see it with your own eyes. The International Space Station is a massive structure orbiting in space. It measures 108 meters in length, 79 meters in width, and 20 meters in height, making it slightly larger than a football field and as tall as a 6-story building. Despite its enormous size, it weighs only around 450 tons. Sending such a massive structure fully assembled into space was never an option. Instead, the ISS was built piece by piece. Each module was launched separately and then assembled in orbit like a giant puzzle floating above Earth. Construction began in 1998 and reached major completion by 2010, taking about 12 years. To achieve this, more than 120 space missions were carried out using rockets from multiple international space agencies. NASA's Space Shuttle was the primary vehicle used to deliver the largest components. Russia's Proton and Soyuz rockets launched several key modules and crew members. Europe's Ariane 5 rocket, operated by the European Space Agency, delivered cargo modules. Japan's H-2B rocket was used to send up supplies and external components. The ISS is a true global engineering marvel, a symbol of international cooperation, and one of the most ambitious space projects humanity has ever undertaken. The International Space Station is not standing still in space. It is constantly orbiting Earth at an astonishing speed of around 28,000 kilometers per hour. For comparison, a commercial airplane typically cruises at just 1,000 kilometers per hour. That means the ISS travels 28 times faster than a passenger jet. This speed translates to about 8 kilometers per second. At that rate, a spacecraft could travel from London to New York in just about 12 minutes. Because of this tremendous velocity, the ISS completes one full orbit around Earth in roughly 90 minutes. In a single 24-hour day, it circles the planet about 16 times. That means astronauts aboard the ISS witness 16 sunrises and 16 sunsets every single day. Now, here's what makes it even more incredible. The assembly of the ISS took place while it was orbiting Earth at this exact speed. Each module was added one by one, all while the station was flying at 28,000 kilometers per hour. It gives you a sense of just how complex and precise this construction had to be. And it does not stop there. Even today, astronauts and cargo are transported to and from the ISS while it is traveling at this speed. For instance, when SpaceX's Crew Dragon brought Sunita Williams back from the station, it had to chase the ISS, match its speed, and dock with it, all while both were orbiting Earth at hypersonic velocity. Today, you can track the path of the International Space Station in real time. Several websites show exactly where the ISS is on its orbit and which part of Earth it is currently flying over. In addition to that, there is also a live video feed available on YouTube, showing real-time views of Earth from cameras installed on the ISS itself. By combining this live feed with the satellite tracking data, you can verify whether the view from the camera matches the location shown on the map, as long as you have a basic understanding of how to read a map. And if the ISS happens to be flying over your region during a clear night, then along with the two sources of information mentioned above, you can step outside and actually see it pass overhead with your own eyes. No telescope is needed. It appears as a bright, fast-moving star in the night sky. The reason I am emphasizing this so much is because there are still a few people who claim that the International Space Station does not exist, and that the videos we see from space are just computer-generated graphics. But with publicly accessible data and direct visual observation, anyone can verify that the ISS is real and orbiting right above us. Although the main modules of the International Space Station became fully operational in 2010, continuous human presence on the ISS actually began much earlier, on November 2nd, 2000. From that day onward, there have always been at least 2 astronauts or cosmonauts aboard the station at any given time. As of now, 283 individuals from 23 different countries have visited the ISS. These include both NASA astronauts and Russian cosmonauts. Astronauts and cosmonauts are both space travelers. The only difference is that cosmonauts are trained in Russia, while astronauts are trained outside Russia. Among NASA astronauts, Peggy Whitson holds the record for the most time spent on the ISS, with a total of 675 days. In second place is astronaut Sunita Williams, with 609 days in space. These values represent cumulative days, accumulated over multiple missions. The record for the longest single continuous stay on the ISS by an astronaut is held by Frank Rubio, who spent 371 days in orbit. His mission was originally scheduled for just 180 days, but due to a technical issue with Russia's Soyuz spacecraft, he had to remain on the station for over a year. A similar situation occurred with Sunita Williams and Butch Wilmore, who were initially scheduled to stay for just 8 days. Due to delays, their mission extended to 286 consecutive days. For Sunita Williams, this was her third visit to the ISS, and her total time on board, combining all missions, adds up to 608 days. But if we include Russian cosmonauts in the ranking, these records are surpassed. Oleg Kononenko, a veteran cosmonaut, has spent a total of 1,111 days aboard the ISS across multiple missions. He also holds the current record for the longest single stretch, along with Nikolai Chubb, both having stayed 374 days continuously. In short, there are even a few individuals who have spent more than a full year continuously aboard the ISS, a remarkable feat of both human endurance and engineering. Many people have stayed aboard the International Space Station for extended periods, but life on the ISS is far from easy. especially when it comes to health. One of the biggest challenges astronauts face in space is the effect of microgravity on the human body. Microgravity means that inside the ISS, astronauts do not feel the pull of gravity. They experience weightlessness. However, this is not because gravity is absent at that altitude. In fact, at 400 kilometers above Earth, gravity is still about 90% as strong as it is at the surface. The reason astronauts float is because the ISS is constantly falling, orbiting Earth at high speed, creating a continuous state of free fall. While this microgravity environment is useful for experiments, it takes a toll on the human body, which has evolved under Earth's gravity. For example, one of the primary functions of our bones and muscles is to support our body weight. In space, with no weight to support, the bones begin to lose calcium and weaken, and the muscles shrink and lose strength, a condition known as muscle atrophy. Although astronauts exercise daily on the ISS to reduce these effects, those who stay for many months still experience significant losses in both bone density and muscle mass. There are other side effects as well. Inside our bodies, fluids like blood, lymph, and spinal fluid are normally pulled downward by gravity. In space, these fluids tend to shift upward toward the head, increasing pressure in the brain and eyes. This can sometimes affect vision. Also, as we mentioned earlier, astronauts aboard the ISS see 16 sunrises and 16 sunsets every day. This confuses the body's natural circadian rhythm, disrupting sleep and wake cycles. Sleep deprivation is a common issue on the ISS. On top of that, spending long periods in a confined space with only a small crew can also lead to psychological stress. The good news is that most of these health effects are temporary. Once astronauts return to Earth, their muscle mass, bone density, and sleep patterns gradually return to normal. However, the recovery takes time and requires specific rehabilitation protocols. There is one more serious health risk astronauts face: radiation exposure. On Earth, our atmosphere protects us from cosmic rays. But since the ISS is outside the atmosphere, astronauts are exposed to much higher levels of radiation. This increases the long-term risk of diseases like cancer. That is why space agencies limit the maximum duration an astronaut can stay on the ISS. In some cases, astronauts have even reported seeing brief flashes of light, even with their eyes closed. These are caused by high-energy cosmic rays passing through the fluids inside the eye and interacting with the retina or optic nerve. As mentioned earlier, the International Space Station has had continuous human presence for over 24 years. Under normal conditions, there are usually 6 or 7 people on board. However, during certain crew changeovers, the number has gone up, sometimes even reaching 11 or 13 astronauts on board at the same time. These situations are temporary and usually last only a few days. The ISS is designed to comfortably support up to 7 crew members for extended durations. Even when Sunita Williams and Butch Wilmore unexpectedly had to stay on the ISS for 9 months, there were other astronauts aboard. They were not alone. The key to supporting human life in space lies in the station's life support system. One of its most critical components is oxygen. On the ISS, oxygen is produced by splitting water molecules into hydrogen and oxygen through a process called electrolysis. In the early years, the byproduct hydrogen was simply vented into space, which meant the water used in the process was gradually lost. But today, things are more efficient. Instead of venting the hydrogen, it is combined with carbon dioxide exhaled by the astronauts to produce water again using a chemical reaction known as the Sabatier process. This allows the water used for electrolysis to be recycled, making the oxygen generation loop far more sustainable. All of this requires energy, and the ISS gets its electrical power from the sun. Its large solar panel arrays can generate up to 120 kilowatts of electricity. On average, the station consumes around 90 kilowatts, which is well within its capacity. The second major component of the life support system is water. About 90 to 95% of the water on the ISS is recycled. This includes sweat, water vapor from breath, urine, and even the water used for hygiene. Nothing is wasted. In fact, astronauts on the ISS often joke, "Today's coffee is tomorrow's coffee." In other words, the water you use to brew your coffee today might be the same water recycled into tomorrow's coffee. That might sound a little unsettling at first, but here is something important to remember. The total amount of water never increases or decreases even here on Earth. It just keeps getting recycled. So the water you drink every day may very well have passed through another living organism at some point, perhaps even through a dinosaur or another human being. Water is just H2O. Once purified, it is chemically identical, no matter where it came from. As long as we can separate those molecules from any impurities, even the dirtiest water can be turned into perfectly clean drinking water. In fact, the recycled water on the ISS is often cleaner and purer than most high-end bottled water available on Earth. As for food, astronauts rely on pre-packaged meals that are sent from Earth. These are carefully stored and manage to last long periods without spoiling. So far, we have looked at the most basic needs covered by the ISS life support system. But for astronauts to live aboard the ISS for months at a time, just the essentials are not enough. They also need various other facilities, especially space. On Earth, we usually talk about space in terms of square feet, like a 1,000 square foot apartment. But on the ISS, there is no concept of walking on a floor. Everything happens in microgravity, where there is no up or down. So instead of square footage, the relevant measure is volume, the total three-dimensional space people can occupy. The ISS has around 13,700 cubic feet of human occupiable volume. To imagine this better, it is roughly equivalent to the usable space inside a 1,000 square foot apartment. This space is divided for different purposes. About 50% is used for official work and scientific experiments. Around 10% is for storage. The remaining 40% is reserved for the crew's personal and daily needs. This includes areas for preparing and eating food, a small gym for exercise, a bathroom, sleeping quarters, and a tiny recreation space. Each astronaut gets a personal sleeping pod about the size of a phone booth. Inside that space, they sleep while floating, since there is no gravity to lie down on a bed. To avoid drifting around while asleep, astronauts secure themselves using restraints or sleeping bags attached to the walls. There are 6 permanent sleeping quarters on the ISS, and they are arranged in different directions, some vertically, some sideways. This often leads to a funny first impression that some of them are sleeping upside down, but in reality, there is no upside down in space. Our sense of up and down only exists because of Earth's gravity. On the ISS, where gravity is not felt, there is no such thing as above or below. No matter how you are oriented, standing, floating, or sleeping, it all feels the same. As for recreation, astronauts have a small area where they can watch movies or video call their families on Earth. In the isolation of space, even a few minutes spent in that tiny space can bring some much-needed comfort. Now let us ask the big question, why was the International Space Station built in the first place? What is the purpose of maintaining such a massive and incredibly expensive structure in space? The ISS provides a unique advantage that we cannot replicate on Earth, the environment of microgravity. On Earth, gravity affects every scientific experiment. For example, in a typical chemical reaction, denser substances tend to settle at the bottom of a solution, while lighter gases rise as bubbles. But in microgravity, these gravitational separations do not occur. All the elements in a reaction stay uniformly mixed, allowing scientists to observe the reaction in a completely different way. Even the shape of a flame in space is different from what we see on Earth. This is something we have seen in a previous video. All of this is due to the absence of gravity. These are just simple examples to show how microgravity affects experiments. In reality, the ISS enables dozens of experiments in physics, chemistry, and biology that would be impossible to conduct on Earth. Research aboard the ISS has already contributed valuable insights into diseases such as cancer and Alzheimer's. Another major purpose of the ISS is to study the human body in microgravity. Since future space missions may involve long-term travel to the Moon, Mars, or beyond, it is important to understand how microgravity affects the body over time. The ISS helps us prepare for those journeys. A second unique advantage of the ISS is that it exists outside Earth's atmosphere. Many types of cosmic particles and high-energy radiation do not reach Earth's surface because they are blocked by the atmosphere, but the ISS is exposed to them. This makes it a valuable platform for studying space radiation directly. While many satellites have been launched for this purpose, they do not carry human researchers. The presence of humans aboard the ISS allows such studies to be conducted live, with direct feedback. The third major mission of the ISS is to help study Earth's climate and environment. Because it orbits Earth about 16 times a day, the ISS can scan a vast portion of the planet's surface. While it is not a satellite specifically designed for Earth observation, it can still provide valuable data. Events like hurricanes, wildfires, and floods can be studied from space using ISS instruments, and sometimes observations from the crew themselves. In short, the ISS serves many purposes, from advancing fundamental science to helping us prepare for future exploration and even supporting Earth observation. That is why, despite the enormous cost and complexity, humanity has built and maintained this incredible structure in space. Now let us look at some of the major dangers faced by the International Space Station. One of the most serious threats is fire. In the confined environment of the ISS, an uncontrolled fire can quickly become life-threatening. That is why extreme precautions are taken to prevent such incidents. And fortunately, no major fire has ever occurred on board. Another serious concern is the leakage of toxic or hazardous substances. The ISS is a sealed environment with limited oxygen. If any chemical or biological material were to leak inside, even in small quantities, it could create a dangerous and potentially fatal situation. But perhaps the biggest threat comes from outside, from the very orbit in which the ISS travels. The station orbits in low Earth orbit, an area crowded with space junk. These are remnants of old satellites, broken rocket parts, and debris created by human activity in space. These objects travel at incredibly high speeds, often 10 times faster than a speeding bullet. If even a small piece of space debris were to collide with the ISS, it could puncture the outer hull, causing a rapid drop in internal pressure, a life-threatening emergency for everyone on board. And it is not just man-made debris. Micrometeorites, tiny natural space rocks just a few millimeters across, can also pose similar risks. To minimize the danger, the outer walls of the ISS are built using materials that are as strong as bulletproof armor. Still, no material can guarantee complete safety from high-speed impacts. Space agencies like NASA and its international partners constantly monitor regions of space with high debris concentration. When necessary, they slightly adjust the ISS's orbit to avoid potential collisions. But despite these efforts, the possibility of a hit can never be ruled out entirely. So, what happens if the ISS is ever damaged or becomes uninhabitable? To prepare for such emergencies, there are always 1 or 2 spacecraft docked to the station at all times, ready to evacuate the crew. Whenever a new crew arrives, they bring a fresh spacecraft with them, which then serves as the new standby escape vehicle. The older one is used for returning astronauts to Earth. This rotation system ensures that there is always a fully operational emergency craft available at the station. We hope this video helped you understand the International Space Station better and perhaps made you appreciate the risks and efforts involved in maintaining a human presence in space. If you enjoyed this video, please like and share it. And for more such content, subscribe to the channel and enable the bell icon so you never miss an update. Thank you.